Picture a brand new life entering the world. Utterly dependent, fragile, taking its first breaths. But what if, right from that moment, unseen, there's this fundamental biological challenge waiting? A hidden vulnerability that could dictate its very survival. Welcome to the deep dive. Today our mission is to unpack precisely such a challenge, failure of passive transfer, or FPT. We've taken a stack of sources, articles, research, our own notes, and our deep dive today explores this critical immunological hurdle in a really interesting pair of animals. We're talking about the graceful camelids, so think llamas, alpacas, camels, and also the various deer species, collectively known as cervids.
Yeah, and what's so fascinating, I think, is that this isn't just about animal health in a, narrow sense. It's really about a fundamental immunological process, one that's absolutely crucial for survival. See, unlike species like us, humans, with hemocorial placentas, where antibodies transfer directly across the placenta before birth, ungulates, so that's species like calves, crias, baby llamas or alpacas and fawns, they're born functionally a gamma-globulin-anemic.
Okay, that's a big word.
It is a mouthful. But it basically just means they lack any circulating antibodies at birth, none. They are entirely reliant on that special first milk called colostrum for all their initial passive immunity.
Right, so they're essentially born without any immune defense. So what exactly is failure of passive transfer, and why is this colostrum so incredibly vital for them?
FPT is pretty much what it sounds like. It's a condition where these neonates, these newborns, they just don't receive an adequate amount of immunoglobulins, mainly IgG, from that colostrum shortly after birth. And this deficiency, well, it leaves them incredibly susceptible to all sorts of infections. It leads to increased illness and morbidity, we call it, and sadly, much higher mortality rates. Colostrum, then, is the absolute cornerstone of neonatal immunity for these animals. It's this complex biological fluid produced by the mother, the dam, right after giving birth.
And it's more than just antibodies, right?
Oh, absolutely. Its composition is truly remarkable. While immunoglobulin G, IgG, is the primary component for systemic protection, throughout the body, colostrum also contains IgA and IgM. Those are crucial for mucosal immunity, especially in the gut lining. But it's not just antibodies. It's packed with other non-nutritive bioactive components, things like growth factors, even antimicrobial proteins like lactoferrin. And what's critical to understand is that colostrum quality isn't static. It's heavily influenced by maternal factors during late gestation.
Such as?
Well, things like parity. So if it's a first-time mother, she might produce lower quality colostrum. Also, the length of her dry period before birth, her overall nutritional status, and even stressors like excessive heat can actually impair the transfer of immunoglobulins into the mammary gland. It really underscores how preventing this neonatal immune deficiency is intrinsically linked to comprehensive maternal health management, right through that whole peripaturian period around birth.
Okay, so given that incredibly rich and vital composition of colostrum, the timing of getting it must be absolutely critical, right? Is that where this open gut phenomenon comes in? Tell us more about that ticking clock.
Exactly. The neonatal intestine has this remarkable but very transient, very short-lived ability to absorb large, intact protein molecules directly into the bloodstream. It happens through specialized intestinal cells that essentially engulf these big molecules.
Yeah.
Non-selective penocytosis is a technical term.
Like tiny sponges?
Kind of, yeah, like tiny temporary sponges that can only soak up these large proteins for a short time right after birth. And this open gut phenomenon is what allows those vital immunoglobulins from the colostrum to be absorbed and establish that systemic passive immunity. But, and this is really crucial, this window of opportunity is extremely time sensitive. The absorptive capacity is maximal immediately after birth and then declines incredibly rapidly.
How rapid?
Very. Those specialized gut cells, the enterocytes, they're quickly replaced by mature cells that simply can't absorb intact proteins anymore. We call it gut closure. And the gut is considered effectively closed by 24 hours of age, maybe even sooner for some functions. So this physiological deadline establishes this profound urgency for the neonate to get its first colostrum feeding as soon as possible. Yeah. Ideally within the first, say, 3 to 6 hours of life to really maximize that immunoglobulin uptake.
Wow, okay, 3 to 6 hours, that's not long at all. So if colostrum is so vital and this absorption window is so incredibly narrow, what typically leads to FPT? What goes wrong in that process?
Yeah, it's often multifactorial.
Yeah.
And many causes are actually common to both camelids and cervids. We can sort of group them into three main buckets. First, there's inadequate colostrum intake.
Meaning the baby just doesn't drink enough.
Right. This can happen if the neonate is weak or premature, Maybe there's poor maternal bonding, or the mother doesn't produce enough milk, or maybe she has poor udder conformation, making it hard to nurse. A difficult birth can also lead to a compromised neonate that's slow to get up and nurse. And for cria specifically, there are congenital defects like choanal atresia.
That's the blocked nasal passage thing.
Exactly, a blockage of the nasal passages, which obviously prevents effective nursing. Second bucket, poor colostrum quality. This is usually down to maternal health issues, maybe inadequate nutrition for the dam during pregnancy, or even premature lactation before both, which dilutes the good stuff. And third, just delayed colostrum feeding, simply failing to nurse within that critical time window.
Which is roughly?
Well, the first 6 to 12 hours generally. For cria, some research suggests an even tighter critical 16 to 18-hour window for really optimal gut absorption.
Yeah.
But the earlier the better, always.
That makes sense. So if a neonate is facing FPT, what are the telltale signs? What should people be looking for?
Good question. It's important to distinguish between two types, really. There's subclinical FPT.
Subclinical, meaning no obvious signs.
Pretty much. The neonates may initially appear quite normal, but they'll show increased susceptibility to infections later on. And generally, they have poor growth rates. They might just seem a bit off or unthrifty without being clearly sick. Then there's clinical FPT. Right. And here you start seeing clear signs of systemic infection.
Like what?
Things like fever, lethargy, diarrhea is a big one, respiratory distress, maybe swollen joints, that's joint ill, or has septic arthritis. You might also notice just general weakness, an inability to stand or nurse properly, or a clear failure to gain weight like their siblings. Untreated cases, sadly, have very high mortality rates. And for cervids, especially fawns, sudden death is unfortunately possible in severe FPT situations.
Okay, so if FPT is suspected, how do we actually confirm it? What's the diagnostic quest like, from the high-tech lab down to the farm level?
Right. The primary diagnostic method, the sort of benchmark, is measuring serum IgG levels. That's immunoglobulin G in the blood. This is typically done 24 to 48 hours after birth, giving them time to absorb whatever colostrum they got. For both camelids and cervids, adequate passive transfer usually means they need to have more than 800 milligrams per deciliter mgdl of IgG in their blood.
800 milligdl.
Yeah. For cria specifically, the accepted threshold is actually a bit higher, over 1,000 milligdl. And in camelids, we also classify FPT further. So partial FPT is between 400 and 800 milligdl, and complete FPT is less than 400 milligdl.
And how does that compare to other animals?
Well, for context, the dairy calf model, which is where a lot of FPT research comes from, considers anything under 1,000 milligdl as FPT. And they even have a tiered system for different levels of immune status. So the 1,000 mark for crias fits in that context.
Got it. And what about the actual tools? Can you run a test right there on the farm, or does it always need a lab?
You definitely can do on-farm testing, which is crucial for timely decisions. Now, the gold standard for accuracy is a lab test called radial immunodiffusion, or RID.
Gold standard, but slow.
Exactly. It's incredibly precise, but it's slow.
Yeah.
You're looking at an 18-plus hour turnaround time, which, isn't practical when you have a potentially sick neonate right in front of you. Immunoturbidometry is a newer, rapid quantitative lab method that's faster in gaining traction. But for on-farm and screening purposes, the most common tools are total protein, or TP, refractometry, and Brix refractometry.
Refractometers, like they use for grapes or honey.
Exactly like that. They measure total solids or total protein in the serum. And what's really a key diagnostic advantage, especially in alpaca colostrum, is that there's an incredibly strong positive correlation. The R value is 0.91, which is remarkably high between the concentration of IgG in the colostrum and the total protein content.
Wow, 0.91, that's almost a perfect match.
It's very, very strong. It means these two measurements track each other almost perfectly. So this makes a simple handheld refractometer a really powerful, accessible tool for assessing colostrum quality in real time right there on the farm.
And for testing the cria itself.
Yes, you can use it on the cria serum too. For camelids, serum TP levels below about 5.5 to 6.0 grams per deciliter often suggest FPT. For cervids, it's similar. A serum TP level below 5 GDL in mule deer and serum Brix values over 8.9% white-tailed deer seem to be strong predictors, though we definitely need more species-specific cutoff points for cervids.
Are there other tests people might hear about?
Yeah, some older tests like glutaraldehyde coagulation and sodium sulfite precipitation, they're generally considered inaccurate for llamas and aren't recommended anymore. Gamma-glutamyl transferase, or GGT, which is an enzyme absorbed from colostrum, shows some utility, but it's imperfect and varies a lot by species. So refractometry is really the go-to field test.
That strong correlation with the refractometer in alpacas is fascinating. It makes things so practical. But it also brings us to something you mentioned earlier, this idea of the paradox of plenty, specifically for camelids. What does that mean? Are they, like, too good at making colostrum?
It's a really interesting concept, this paradox. See, camelid colostrum actually has exceptionally high concentrations of immunoglobulins compared to many other species. For example, alpaca colostrum averages around 26,300 milligdl of IgG. Llama colostrum is around 23,000 milligdl.
Than cattle.
Cattle colostrum is typically much lower, maybe around 6,000 to 10,000 milligdl, roughly. So camelids are often packing 2 to 3 times more IgD into their colostrum. So this paradox of plenty suggests that while that 1,000 milligdl level in the courageous blood is the minimum for adequacy, the point where we say they haven't failed, the biological optimum for a truly healthy, thriving creels is likely much higher.
So just scraping past the minimum isn't necessarily ideal.
Exactly. A creo with a serum IgG of, say, 1,200 milligdl, while technically passing the FPT test, might still represent a kind of partial failure relative to its genetic potential and the sheer abundance of IgG that was available in the colostrum. It really reframes the goal. It's not just about avoiding failure, it's about actively pursuing an optimal state of immunity for that individual.
That's a really important shift in perspective. So, okay, let's say FPT is diagnosed, or maybe you suspect a chorea hasn't reached that optimal level. What are the immediate steps for treatment? What can actually be done?
Right, the treatment strategy really depends on how quickly FPT is identified, specifically relative to that 24-hour gut closure window. If FPT is diagnosed within the first 24 hours, while that crucial gut barrier is still open for absorption—
You can still give colostrum orally.
Precisely.
Yeah.
The primary treatment, then, is oral administration of high-quality colostrum. The ideal source, if possible, is banked, frozen colostrum from other healthy camelids on the same farm. That provides species-specific antibodies tailored to the local environment.
What if that's not available? Can you use cow colostrum?
You can use cow colostrum as an alternative, but it's not ideal. The absorption rates in crias are known to be highly variable, sometimes as low as 2%, maybe up to 26% in some studies. And crucially, it doesn't provide those camelid-specific antibodies. For cervids, the options are often deer colostrum if available, or sometimes goat or cow colostrum is used.
Okay, but what if you miss that 24-hour window? Or if it's a case of complete FPT, very low IgG?
Yeah, for neonates older than 24 hours, or those with complete FPT, when that intestinal barrier is effectively closed to large molecules, oral colostrum won't help much with systemic immunity. In those cases, plasma transfusion is required.
Giving them plasma directly?
Yes. Using commercial or farm-sourced camelid plasma provides a direct infusion of IgG right into the bloodstream. The intravenous or IAV route is generally the safest and most effective way to do this. But, and this is really critical to recognize, plasma transfusion isn't some kind of standalone magic cure, especially if the caretaker is already sick. It is a vital supportive measure, but it must be integrated into a comprehensive treatment plan. That often includes things like systemic antibiotics if there's infection, anti-inflammatory medications, IV fluids for hydration, and nutritional support.
Right, it buys them time and gives their immune system a boost, but doesn't fix underlying issues.
Exactly. It provides the missing antibodies, but you still have to treat any ongoing infection or other problems.
Makes sense. So, beyond treating FPT once it's happened, how can we prevent it in the first place? What are the key proactive measures for these animals?
Prevention is always better, of course. General prevention really focuses on ensuring early and adequate colostrum intake. That means closely monitoring neonates right after birth to make sure they stand and nurse effectively and quickly. Implementing colostrum quality control is also huge. This means actually testing the colostrum from the dams, using refractometry, for example, and ideally storing frozen backup colostrum from healthy mothers, a colostrum bank.
So you have good stuff ready if needed.
Precisely. And fundamentally, ensuring the pregnant females receive proper nutrition and health care throughout their gestation is paramount. That helps them produce high-quality colostrum in the first place. Now, for farmed cervids, prevention centers more on intensive herd health and biosecurity protocols, maintaining really clean calving or fawning environments, strict disinfection protocols, quarantining any new animals brought onto the farm, and again, using banked or carefully sourced supplemental colostrum for any swans identified as being at risk.
And what about wild cervids? You can't exactly run out and give them colostrum.
No, exactly. For wild cervids, direct intervention is obviously impossible, so management has to be indirect and ecologically focused. The primary strategy there is habitat management. The goal is to improve the nutritional plane, the quality of food available for the daws, particularly during late gestation and early lactation. Better nutrition supports higher quality colostrum production and leads to more robust fawns that are quicker to nurse. Herd management strategies can also play a role, like promoting a healthy age structure in the herd, perhaps by selectively protecting mature, experienced does who tend to be better mothers. This can enhance overall fawn recruitment rates.
This really broadens the scope. It raises an incredibly important question. How does FPT extend beyond just individual animals? How does it influence entire wild populations, perhaps in surprising ways? Does it play a role in larger ecological dynamics?
Oh, it absolutely does, and it's a profound implication, especially in wildlife ecology. FPT directly increases the risk of early mortality in fawns, not just from infectious diseases like bacterial scours or pneumonia, but also from things like emaciation and starvation because they're just not thriving. However, perhaps the most profound implication of FPT in wild populations is its role as an ultimate, often hidden cause of mortality that is frequently misattributed entirely to predation.
Wait, hang on. Are you saying what often looks like straightforward predation, a wolf or coyote takes a fawn, might actually be a symptom of something deeper? That predation might not be the whole story in many fawn deaths.
That's exactly what the evidence increasingly suggests. This is where the concept of the doomed surplus comes into play. Think about it. A fawn with a compromised immune system due to FPT is far more susceptible to common environmental pathogens. It gets sick easily. A sick, weak, maybe lethargic fawn is an exponentially easier target for any predator compared to a healthy, vigorous one.
Right, it can't run as fast, it's less alert.
Exactly. So when a predator takes this already compromised individual, the proximate cause of death, the immediate cause, is recorded as predation. But that masks the ultimate physiological failure, the FPT, that truly made it vulnerable in the first place.
Has this been studied?
Yes, some fascinating studies have been conducted in predator-free environments or areas with very low predator densities. And even there, fawn mortality from natural causes, often linked to disease or starvation, can be really high, sometimes as high as 55%. That rate is comparable to mortality rates seen in areas with high predator populations.
Wow. So predators might just be removing the fawns that were likely to die anyway.
To a significant extent, yes. They're removing the doomed surplus. This fundamentally challenges traditional wildlife management strategies that focus heavily, sometimes almost exclusively, on predator control as the primary way to increase fawn survival. It suggests that such efforts might be largely ineffective, or at least less effective than thought, if underlying maternal and neonatal health issues like FPT are the true limiting factor.
And environmental factors play into this too.
Definitely. Environmental stressors like periods of heavy rainfall right after birth, chronic nutritional stress in the due to poor habitat, even elevated stress hormones like cortisol in the fawns themselves can further exacerbate this dynamic, making those fawns even more vulnerable to both disease and predation.
That's quite a revelation. It really flips the script on how we might think about predator-prey dynamics and fawn survival. So, bringing it all together, when we compare camelids and cervids side by side on this issue of FPT, what are the key differences? How does it play out across these two distinct groups? What are the big comparative takeaways?
Yeah, looking at them together highlights some profound differences. And these were largely driven by their distinct evolutionary adaptations and, importantly, the very different contexts in which humans manage them. First, let's circle back to colostrum composition. We touched on it, but that striking difference in IgG concentration is really remarkable. You have alpaca colostrum averaging, 26,319 mg/dl versus red deer, which is known to be lower, and cattle weigh down around 6,000, 10,000 mg/dl.
A huge difference.
Massive. This vast disparity likely reflects different evolutionary pressures over millennia. And don't forget those unique heavy chain antibodies, the HCCABs, in camelids, which can make up 75–80% of their total circulating IgG. Cervids don't have those. Second, there's a significant diagnostic divide. Think about it. For high-value, individually managed camelids on a farm, the focus is heavily on rapid animal side tests, like the Brix refractometry we discussed, because of that strong IgG correlation.
Right, you need answers quickly for that specific animal.
Exactly. It allows for immediate clinical intervention. For cervids, especially wild populations, diagnosis is far more challenging, often impossible on an individual level. It becomes less about treating an individual and more about assessing population health trends. You often rely on a panel of indirect tests during research studies, or FPT is inferred retrospectively by looking at patterns in fawn mortality. And third, flowing from that, are the divergent management paradigms.
Intervention versus ecology.
Precisely. For camelids, the approach is largely reactive and interventionist. You identify FPT, and you treat aggressively with tools like plasma transfusion and supportive care for that individual carrier. For cervids, particularly wild populations where individual treatment just isn't feasible, management has to be proactive and preventative. It focuses on the bigger picture. Habitat management to improve nutrition, and perhaps herd management strategies that favor successful, experienced mothers.
That's a really powerful distinction, the individual, reactive intervention versus the broader, proactive habitat and population management. So let's boil this all down. What does this mean for you, our listeners? Whether you're a vet, a camelid producer, a wildlife manager, or just someone fascinated by animal biology and ecology, what are the most important takeaways, maybe recommendations from this deep dive?
Okay, let's try to distill some actionable insights. For veterinarians and camelid producers working with llamas and alpacas, first, absolutely implement routine colostrum quality control. Using a Brix refractometer is simple, cheap, and effective. And alongside that, establish formal colostrum banking programs on your farm. Freeze high-quality stuff. Second, standardize neonatal screening for all cryas, probably around 48 hours of age, using serum Brix or total protein refractometry. It's cost-effective and gives you crucial information early on. Third, we urgently need more research, as we discussed, to establish optimal, rather than just barely adequate, serum IgG targets for cryas. We need to aim higher than just avoiding failure, given that paradox of plenty. And finally, for this group, really understand that plasma transfusion, while a lifesaver, is just one component. It needs to be part of a broader supportive care strategy that includes diagnosing potential sepsis, appropriate antimicrobial therapy, and fluid and nutritional support.
Okay, and what about for the wildlife managers and cervid researchers out there?
For them, I think the biggest message is reevaluate the perceived role of predation in fawn mortality. Actively incorporate measures of maternal and neonatal health into mortality investigations. Look at doe body condition scores, fawn birth weights, conduct thorough post-mortem analyses on found carcasses. Try to disentangle the proximate causes, like predation, from the ultimate underlying causes, like FPT-induced vulnerability. Second, prioritize habitat management specifically aimed at enhancing nutrition for does during those critical late gestation and early lactation periods. Healthy moms make healthy babies with good colostrum. And third, invest time and resources into investigating non-invasive health indicators, things like fecal glucocorticoid metabolites, for example. These can help us understand how environmental stressors are truly impacting maternal physiology, colostrum quality, and ultimately FPT rates in wild, unhandled populations.
Wow. It really is a journey, isn't it? From the struggle of a single newborn curia or fawn trying to get that first vital drink, all the way to the complex dynamics shaping entire wild populations and even challenging our assumptions about predator-prey relationships. FPT truly shows how a seemingly small, time-sensitive biological process, getting enough good colostrum quickly, can have such massive cascading consequences. It really highlights the critical timing, the diverse diagnostic tools we have now, and these surprisingly profound ecological implications, especially for wild cervids, that ripple right through ecosystems.
Absolutely. And if we connect this to the bigger picture, maybe leave you with a final thought. This raises a really important question, doesn't it? How many other hidden biological vulnerabilities like this might be shaping the populations around us, influencing survival, reproductive success, even predator-prey dynamics, just waiting there under the surface for a deep dive like this to uncover their true impact? It really makes you consider the intricate interconnectedness of all these seemingly disparate biological and ecological factors.